Okay, so today we're going to start Chapter 5, Section 1. Now you may think, wait a minute, we just finished Chapter 5 and took a test on it. However, this is Chapter 5 content from our old textbook. And our new textbook jumps right into the trigonometry in radians. And for most of the time or exposure you've seen trigonometry and angles, we've always done it in degrees. So we're going to go ahead and cover the content first, calculating everything using degrees, and then we're going to do the exact same thing again, and we're going to do it in radians from our textbook. So because this is coming from an older textbook, your homework for this chapter from the Brown Book is going to be PDFs. Now, in the module, I've posted a file that has the answers to the odd questions. So when you're doing your homework, you can check your answers. It doesn't have the work, so you're still doing the homework, but it's a PDF. But if you just go to that file and copy the answers down with no work to back it up, you're not going to get credit for the homework. So you're still showing work, but you at least can check your answers to see if you're on the right track. So today we're going to start Section 1, and it's our introduction to trigonometry. But what we're going to talk about today are angles. So we're going to be looking at degrees on a coordinate plane. So what I'm referring to is this will be our x-axis, and this is going to be our y-axis. So this is what I'm referring to when I'm talking about degrees in a coordinate plane. Now, prior to this, in geometry, you learned about acute angles and right angles and obtuse angles. However, what we're going to be looking at in this chapter are angles that are greater than 360. And we're also going to be looking at negative angles. And that's all going to determine your rotation direction. So when your angle of rotation is positive, it's like going around your coordinate plane counterclockwise. But when it's a negative angle of rotation, it's going to be clockwise. So some key points or key things to be aware of is over here on the left side of your x-axis, this is going to be 0 degrees. So right here where this arrow is, up here at the top will be 90 degrees, because if you think about it, this would be a little right angle right here if you were to form it. Over here on the left side of the x-axis, this would be 180 degrees. So for example, if you went all the way around, this would measure 180 degrees. Down here at the bottom on your y-axis, this will be 270 degrees. And then once you go full circle all the way around, this would form 360 degrees. So this side of this x-axis, not only is it 0 degrees when you're first starting out, but when you make a full circle, it's 360. Now, one other thing you need to remember, probably back from your middle school days, is that in each quadrant, it's got a name. So the upper left part of your coordinate plane, this is quadrant 1, this will be quadrant 2, quadrant 3, and then down here is quadrant 4. Now, because our angles are going to be swirling around, we need to identify some vocabulary terms. So the starting point or the starting side of your angle is called the initial side. So where you start out. And then where your angle ends up is called the terminal side. And you're going to need to include the little arrows on the ends of the angle when you graph them to show that it's a positive or a negative. Now, if I wanted, in the same thing for the negative angle of rotation, so when you're graphing a positive angle, it goes counterclockwise. When you're graphing a negative angle of rotation, you're going to go clockwise. So down here, if you notice on this one, here is my initial side. It's where I start. But then once I leave that side, then I'm going to come down here, and then my terminal side is where it stops. And that would be, I could say that this looks like it's probably about a negative 30-degree angle because it's going clockwise. If I were to come all the way down here and hit here, remember positive, it's 270, but negative, this would be a negative 90-degree angle. And then over here, this would have been positive 180, but it's also negative 180. And then up here, this would be positive 90, but negative 270. And it all depends on where you're taking off from that initial side. And this is why it's going to be important that you include the arrow when it hits that terminal side. So let's go ahead and let me add another coordinate plane down here, another X and Y axis. And I'm going to graph some angles on here. So let's say, and again, let me go ahead and add in these numbers. So this is, I'm going to do a bunch of positive ones. So 0 and 360, and then over here is 90, 180, 270. So let's say I wanted to graph, say, a 135-degree angle. So I'm going to start off from my initial side, and then let's say I wanted to graph 135 degrees. Well, I could go here 90, and I'm not going to put the arrow yet, and then I'll go a little bit more, another 45 degrees, and I could say that this is 135 degrees. Now, one other thing to be aware of is in quadrant 1, the angle measures are going to be between 1 and 89 degrees. In quadrant 2, the angles are going to be from 91 to 179. In quadrant 3, the angles will be from 181 to 269. And then in quadrant 4, the angle measures are going to be from 271 up to 359. Now we're actually going to graph angles that are larger than 360 because we're going to be swirling around and making larger and larger angles. So let's say I wanted to graph a 240-degree angle. So again, I'm going to start here on my initial side. I'm going to swirl around 90, 180, and if I want to get to 240, I could go an additional 60 degrees, and I could say this is around 240. And notice it's ending up in the correct quadrant. Let's say I wanted to graph. All right, then let's do one that'll end up in quadrant 4. Let's graph a 330-degree angle. So let's say I wanted to graph 330. I'd come around here, 90, 180, 270, and let's say 330, it'll be about here, 270 plus 60 would be around 330. Now, let's say I wanted to graph a 720-degree angle. So what I would do, let me make my X and Y axis. So let's say I want to graph 720. 720, if you think about it, it's 360 plus 360. So you start here, swirl around 360, swirl around again, and show that the arrow hits on this initial and terminal side for this particular problem. So you may have to swirl around multiple times. You may end up stopping part way. But again, be aware of approximately where the cutoffs are. If I wanted, say, a negative angle, remember you go counterclockwise. Go clockwise. So let's say I wanted to graph a negative 135. So I would start this way, go 90, and then 45 more. And this one, the red one, would be a negative 135. So when it's positive, you go counterclockwise. When it's a negative angle, you're going to go clockwise. 720, they both started right here and ended there. You follow?
So it's just one line?
Yeah.
Okay.
For that one, it's just one line. Next, we're going to define what a coterminal angle is. And a coterminal angle is going to have the same initial and terminal sides, but it'll either have more or less rotations around the circle. To find a coterminal angle, all you need to do is add and subtract 360 degrees. You may be asked to give a positive coterminal angle or a negative or both. So, for example, and we're going to do a bunch on the next slide, but let's say, let me draw my coordinate plane here, my X and Y axis. And let's say I draw in a 30-degree angle. So that's going to be my terminal side. My initial side is right here at 0 degrees. So remember, this is 0, this is 90, this is 180. These are all degrees right now, 270. So let's say this is a 30-degree angle. And let's say I want to find a positive coterminal angle to my 30-degree angle. So what I need to do is take 30. To get a positive coterminal angle, I add 360. So that'll be 390 degrees. Remember, coterminal angles have the same initial and same terminal. So positive, I would start here, go around, 360, and then 30 more, and there's my 390. Notice it started at the same spot and it ended at the same spot. The only difference is it swirled around one full circle. Let's find a negative coterminal angle. Now, let's find the negative coterminal angle to the 30 degrees. So I would subtract 360, and this will give me negative 330. So remember, to draw a negative angle, we go clockwise. We start on the same initial side, which is this 0 degrees. So I'm going to go around 90, 180, 270, and then finally the negative 330. Notice it hit this same terminal side. They're both hitting this red ray here, but one, the arrow is on the top of it, and when it's negative, and in this case, the positive was underneath it. They're always going to be on the same initial and terminal sides. Let's try a really large angle. Let's try 700 degrees. 750, sorry. Let's do 750. So, technically, to find a positive coterminal angle, I really don't have to add anything. I could just subtract because I'm still going to have a positive answer. So sometimes you're going to have to subtract or add 360 more than once to get those coterminal angles. To find the positive, you can always just add 360. So I could just add 360 to get my positive coterminal, but then I'd have to graph this. So this would give me a positive coterminal. However, I could still also get a positive coterminal angle by subtracting 360, because when I subtract 750 minus 360, I get 390 degrees. I'm still positive. So this could be a positive answer as well. To get the negative answer, I got to subtract 360 again, but I'm still at a positive answer. So I need to do it one more time to finally get my negative coterminal angle. So sometimes you're going to have to, if your number is really large, your angle, you may have to subtract 360 a bunch of times. Or let's say you have a really small negative number and you may have to add 360 a bunch of times to get a positive. So I would probably, and if I had to graph these, I would have just done the subtraction to get my positive. But again, it doesn't really matter. So again, they may ask you to graph. So let's say we had to graph this. So I'm going to start over here at 0 degrees. So when I start from my positive, I'm going to start here at 0. And then I'll go to the 90, the 180, 270. So for 750, I'm going to swirl around 360, 720, and then I got to go 30 degrees more, and this is going to be my 750 degree original angle. Then if it asked me to find a positive coterminal, I could actually do any one of these three. I could do this one, or this one. Honestly, I'd probably do the 30. It'll be the easiest because notice it starts on the same initial and it ends on the same terminal. However, for the negative coterminal, I got to go clockwise. So I'll start here, go around negative 90, negative 180, negative 270, and end up here for the negative 330 degree angle. So this is negative 90, negative 180, negative 270. So when you're talking about coterminal angles, you're going to be adding and subtracting. So to get a negative, you would be subtracting 360. To get a positive, you would be adding. There's actually an infinite number of coterminal angles because I can keep adding and subtracting 360 and just get super huge numbers or super small numbers. So for the first one, it says find two coterminal angles, one negative, one positive. Now, when you're doing the homework tonight, it's going to ask you for the smallest positive coterminal or the smallest negative. So, in other words, if I wanted a smaller positive coterminal angle, I wouldn't add 360. I would just subtract it here because 908 is so large. So in order to get, technically what I can do is take 908. And if I wanted a positive one, I could just add 360 and I get 1268. This is a positive coterminal angle. And we could keep adding it if we want, because again, it's an infinite number. However, to get the negative coterminals, I need to subtract 360. So 108 minus 360, 548. It's still positive. This could have been my positive answer. I didn't necessarily have to add 360. I still need to subtract another 360. I still need to get a negative number here. Once I do that, I get 188. I'm still positive. So I got to do it one more time. And now I finally have my negative coterminal angle, and I had to actually subtract 360 3 times. So this would be the negative. All of these, the 188, the 548, or even the 1268, these are all positive coterminal angles. Number 2, right below it. So negative 75. So again, to find a positive, I'm going to take negative 75. I'm going to add 360. And this will give me positive 285. This is my positive coterminal. And to get my negative coterminal, negative 75 minus 360. And I get negative 435. So this would be my negative coterminal angle to to the negative 75 degrees. Same thing, it's negative. So in order to get my positive, I can go ahead and take negative 203, add 360, and this will give me positive 157. So that's my positive answer. And to get my negative answer, take negative 203, subtract 360, and I get negative 563. And that will be my negative answer. And again, you could subtract another 360 and another 360 to get more and more negative, or keep adding 360 to get more and more positive. There's an infinite number. Now, number 4, in order to get my positive, what I'm going to do here is I could just subtract 360, because that's still going to give me a positive answer. I don't need to necessarily add, because if I'm having to subtract multiple times, I'm going to go ahead and just take that. So this could be my positive answer. I could have also added 360. So then now, to get my negative, I need to take that 339 and subtract the 360. And now I get negative 21 degrees. And here is my negative answer. We're going to talk about degree, minute, second notation. So when we want to convert from degrees, minutes to seconds, DMS, to a decimal degree, what we're going to do is we're going to go ahead and divide the minutes by 60 and the seconds by 3,600. If we want to convert from a decimal degree to degrees, minutes, seconds, we're going to take the degree, the whole number becomes the degree, then we'll take the decimal portion, multiply it by 60. Then once we get that answer, we take the decimal part and we multiply it by 360. So we're going to see some examples of this. Now, the whole purpose of this, what we saw in geometry, is we never wanted precision. We never wanted to have a super precise angle measure. We usually rounded it to maybe the whole number or the tenths. But what this is doing is giving us a more precise measurement. So for example, let's say you're running a race or running a marathon and you wanted to record your time and you wanted to see if your time gets better each time you run that marathon. You don't want to say, oh, I ran it in 5 hours. You might want to say, I ran it in 5 hours, 2 minutes, 32 seconds. You want to see precision here. And this is what this notation, this degree, minute, seconds, is going to give us for our angle measures. So we're going to go ahead and try some calculations. Now, when you're doing these calculations on your calculator, you're going to need to use parentheses if you're going to do it continuous on your calculator. Now, on the newer calculators, there's actually buttons that will convert it. But by time you put in all the buttons, I think it's almost easier just to divide it by 60 and multiply it by 360. Because once you use the app button, you're going to need to be adding in what looks like quotation marks or single quotes. So it's almost more buttons that you have to push in order to do it. But if you want to play around with your calculator, there is a button and it usually says DMS on it. Or it might even have the word angle on it. And we can practice with that if you want. But honestly, it's easier just to use the multiply and divide by 60 and 3,600. So let's just try some examples converting from degrees, minutes, seconds to a decimal degree, or vice versa, from a decimal degree into degrees, minutes, seconds. So here's our first example. This is given to us. The 74 is the degree. The 8 is the minute, or the minutes. And the 14, these are the seconds. I need to convert this to a decimal degree. So what I'm going to do is I leave the 74 alone. I leave the degree alone. I take the minutes, I divide that by 60. Then I take the seconds and I divide that by 3,600. If you're going to do this continuous on your calculator, you need to put parentheses around it if you're not using the fraction feature. If you're using the division sign to put this in your calculator, then definitely put parentheses around it. Once you do this, you should be getting 74.137 degrees. And this denominator here, this 3,600, this is just 60 times 60. Because there's 60 seconds in a minute and 60 minutes in an hour. Let's say this was our given problem and we wanted to convert it back to DMS, to degrees, minutes, seconds. So to go the other way, what you're going to do is you leave the whole number alone. That becomes your degree. Then for the minutes, what we do is we take the decimal portion. So I take the 137, or the 0.137, and I times that by 60, and then that gives me 8.22. I take the whole number, and that becomes my minutes. And then I take the decimal part, the 0.22, times it by 60 again. And then I get 13.2, and then that becomes my seconds. Now, notice the answer is different from here because, again, these were rounded numbers. So that's how you go from the degrees, minutes, seconds into the decimal degree, or from a decimal degree into degrees, minutes, seconds. Let's try another example going from degrees, minutes, seconds. So I've got DMS here. So in order to convert this to a decimal degree, in your calculator, you'll do 165 plus, and then either enter this as 51 divided by 60 plus 9 divided by 3,600, and then hit enter, and you're going to get 165.8525 rounded to 3 decimal places, 165.853. Now, if you want to do it as a fraction, you could also do 165 plus, and then the 51 over 60, plus 9 over the 3,600. And just play around with your calculator. It's almost easier to do it this way than using that app feature on your calculator. But if you want to use the app feature, you actually have to type in the quotation or the single quote, like the apostrophe. Let's try going the other way now. Now we have the decimal degree, and now let's convert it to degrees, minutes, seconds. So again, the 34, the whole number part, that becomes my degree. I take the decimal portion, the 0.817. So to get my minutes, I take 0.817, times it by 60, and then this is going to give me 49.02. So now my minutes are just the 49. So far I've got 34, and then my minutes are 49. And now I take the decimal part for my seconds, and I'm going to take 0.02. I need to times that by 60. And then now I end up with 1.2. So you can go ahead and just round it to the whole number. So then this shouldn't be a degree symbol. This should be the minutes. So this should be the little single quote or apostrophe, and then that's the quote. So round to the whole number. So 34 degrees, 49 minutes, and 1 second. So if you think about it logically, you could think of like 1.5 hours. So like if you thought about 1 hour and then 30 minutes, to turn that into a decimal degree, you would be dividing this by 60, and that's how you get 1.5. Same idea here. So last one, we're going to leave the 59. So our degree is the 59. Then I have to take the decimal for my minutes. I'm going to take the 0.8754, times that by 60, and then I get 5.2524. The 5 becomes my minute. So far I've got 59 degrees, 5 minutes, and now I have to calculate my seconds. And my seconds, I take the 0.2524, times it by 60, and this will give me 15.144. And again, I'm going to round to the whole number, so just 15. So 59 degrees, 5 minutes, and 15 seconds.